Hi, I'm Alex. How is it going? All right. So I'm going to talk about annotations for safe parallelism. This work is joint with Michael Han from Autodesk and Vikram from the University of Illinois. So our goal is to create a checker that guarantees that parallelism in C++ is safe. And we're going to be targeting fork joint parallelism, so no p-threads or other types of more unstructured parallelism. And the goal is to use this checker on real code, like millions of lines of code that Autodesk has. And two sort of challenges are how to scale these analyses and how to minimize the annotation burden so that big codes can be annotated with minimal effort. So the basics is that this work is based on DPJ, deterministic parallel Java. It's based on region and effect annotations, which we're using attributes in C++ to inject that information into the source. And that provides strong guarantees, such as race freedom and, in certain cases, determinism. Fork joint parallelism, as I said, is the scope of these checker, and we're going to also support atomic sections and scoped locks. We're not really sure about other locking protocols that are more challenging. C++, as opposed to Java, has some additional challenges that we're looking into, such as pointer arithmetic and aliasing that are more complex than what Java has or doesn't. Implicit functions, and there's a long list that goes on. And also we want to focus on library support, both in terms of we are compiling a library that we don't explicitly know in what context it will be called, and also how do you annotate a library to which you don't have the source code, maybe only the header files, to collaborate with this tool. So the plan is to start with a basic checker and deal with all the nice C++ mess. And then the second step would be to minimize the annotation burden through figuring out smart defaults for annotations and then also inferring effect and region annotations. And this second step will be very interesting for me because it's an interesting research question. It's a interprocedural sort of whole program analysis, and the question there is how can you break it down to make it scale to such large code bases. Besides checking code that's already parallel, we envision using this tool for interactive parallelization, where you have the scenarios. You have a programmer, he or she identifies some potential parallelism, creates a parallel loop or forks a function in parallel, and then runs the checker and asks the checker, is what I just did safe? And the checker can come back with different replies, such as yes, that's fine, or no, because X and Y may have a race, or I cannot prove safety because X, Y, Z. And then the programmer will presumably fix this by adding an annotation or tweaking their code. And hopefully that feedback loop will be easy enough for programmers to make this tool useful. And so I think that's all I have. So thank you.